welcome to the first of our fall events. Pleasure having you here. So as you know, we're the New York Technology Council. I'd like to start by thanking our sponsors, in particular our platinum sponsors, EisnerAmper, PowerSpace, Ernst & Young, and Google. And since we last had a UX event back in June, we've added 7 new sponsors, so let me call them out. I won't be doing this every time, but the new ones deserve at least one call out. New York Grant Company, Cassidy Turley, Witham Smith & Brown, Trinet, Citron Cooperman, McGladrey, J.H. Cohen. And that's a testament to the energy in the New York tech scene that in a few months we've been able to add this many sponsors. With that, let me turn it over to Charles Morrow, who will tell us about tonight's event.
Thanks, Eric. Okay, I'd like to start by introducing our speaker tonight. It's Bonnie John. Sort of what Bonnie does has always been extremely interesting to me. She's one of the leading experts in cognitive modeling in the country, if not the world. And her work has formed sort of the basis for some of the more advanced design tools that are going to be increasingly important to more advanced forms of UX design in the future. She has an undergraduate degree from Cooper Union in mechanical engineering, master's from Stanford in mechanical engineering, and then a PhD in cognitive psychology from Stanford. So,
Carnegie Mellon.
Sorry, Carnegie Mellon. One of the great things about the way she puts together her work and the way she thinks about these problems is that because she was essentially an engineering-driven problem solver to start off with, she uses that background and that view on product development to inform her insights through cognitive psychology and the types of tools that she uses. So her lectures and her background I think are unusually profound in the way in which they are directly applicable. She was previously a professor of human-computer in the Human-Computer Interaction Institute at Carnegie Mellon. She's authored a ton of papers and has also created actual cognitive modeling systems and tools for UX design. And she'll be talking about some of that tonight. She's now a research fellow? Research staff member at IBM and has recently moved to New York. So welcome. And I think Bonnie's going to be a tremendous asset to the New York UX and professional usability and engineering community. And turn it over to you. Thank you.
Thank you. Thank you, Charles.
Okay, so the first thing I have to do is get rid of his slides. Get my slides up. And yes, there we go. Okay, great. So Charles told you a little bit about me. What I want to give you a little bit more detail on that. When I was at Bell Labs, I started my professional life at Bell Laboratories. I was a mechanical engineer, as he said, coming out of Stanford. And I was discovering that mechanical engineering was not that exciting at Bell Labs or in the Bell system because basically I was designing boxes around other people's circuits. Okay, and so I very quickly moved into systems engineering, where I was writing those 500-page specifications for data and telecommunication systems. And as I started writing them, I said, is this what I'm writing is going to be a system? Is it going to be easy for people to use? Is it going to be easy for people to learn? So I didn't know anything about people. I had gone through Cooper Union, Stanford as a mechanical engineer. So I started taking psychology courses at night. And I discovered that psychology was not like engineering. In engineering, you'll have a chapter in a book. At the end of the book, there'll be problems. At the end of the chapter, there'll be problems. And in the back of the book are the answers, because there's a way to get to an answer. In psychology, there were names and dates and results, because almost everything was empirical. Everything was an experiment. The name was the person who did the experiment, the date was the date it was done, and maybe you'll remember the results, but mostly people just remember names and dates, psychology. So this was very unsatisfying to me as an engineer. I wanted to be able to not just do the next experiment because that was too late. I was writing specs, and that was going to be built. Bell Labs was forward-looking. They had a large human factors staff, but the way to do things there and elsewhere was you design it, we'll test it. And when you have, some things slipping on one end, and Western Electric telling you that their manufacturing was going to slip, and AT&T marketing telling you had to get the stuff out, the thing that went out the window was that iterative design and testing in the middle. And so I decided to quit my high-paying engineering job and change the world by going to be a slave, otherwise known as a psychology graduate student, because let me tell you, psychology graduate students are not respected, okay? Because if you have an undergraduate degree in psychology, you're pretty much qualified to be a bank teller. And the first entry-level degree in psychology is a PhD. So anyway, I went to go get a PhD in psychology at Carnegie Mellon. I was there as human-computer interaction was being born. You will see later the book. How many people know the book, The Psychology of Human-Computer Interaction? Okay, a couple of people. That was the book that coined the name of the field. The authors were Stu Card and Tom Moran from PARC, who had been CMU PhD students, and their advisor, Alan Newell, who was my advisor. And so I was there at the birth of this field, stayed at Carnegie Mellon because it was really a fabulous place to be. I was faculty in the computer science department until we had a revolution and created a department for human-computer interaction called the HCI Institute. And so every semester, though, Alan Newell, who created many fields in computer science, including AI and HCI and sometimes computer architecture, he would ask me every year, every semester, "Are you a scientist yet, Bonnie, or are you still an engineer?" And I said, "Oh, still an engineer, Alan." And he'd say, "That's fine. The world needs engineers. I'm just checking, because scientists want to know the truth, okay? Engineers want to know what's useful. Is it good enough to get my job done?" Okay, and so he was a real scientist, the epitome of a scientist. He wanted to get to the truth as close as he could, and I just want to know, is this good enough? This good enough? Okay, and we worked together wonderfully. But I've always been an engineer. I want to beat psychology into a form that engineers can use it, and that's what I've been doing since 1983. And you'll hear a bunch about that tonight. Okay, so let's start with some failures. Here's one with telephone operator workstation. A manufacturer of telecommunications equipment invested very heavily in making a new workstation, and they were in negotiations for a $160 million deal with NYNEX. NYNEX didn't want to spend all that much money without testing it to find out how fast they would recoup their investment. So they actually, the system was running, okay, so they chose a central office, they ripped out half the workstations, they put in the new ones in half of it, they trained half their people, they did a controlled field study, as much as you can do a controlled field study, and that took 6 months, okay? And in the meantime, some of the people there knew me from work at CMU, and they said, "Hey, Bonnie, you think you can predict this stuff with your modeling," which is what I do. "Why don't you come and try to predict it as a consultant?" So little me goes out and learns how to be a telephone operator, okay, and does models. Well, 6 months later, their data come in and say that this is going to be against all intuitions and all calculations by the manufacturer. This was really technologically advanced. It was 10 times faster in its communication. It was well-designed GUI. There were so many advantages, but it was slower. And the sale fell through, and my models predicted that way before the data came in. So that's the first failure. $160 million deal fell through, and let me tell you, the other baby bells were thinking about buying this too, and they heard about this. And so that was a problem. Big bucks in this. Here's another story. Tomahawk missiles. quite a while ago, there was a guy named Glenn Osga, who worked for the Navy, and he did a GOMS model, which is, you don't need to know what type of model that is, but it's a type of model that I do. Okay. And he did it on the proposed new launch system for the Tomahawk missiles. And his predictions said, these won't work. The client, the customer, who was part of the Navy, okay, didn't like this report, so they buried it. The system was built as designed, and it failed its acceptance test. Okay, and then years later, this is the great part, okay, there was a workshop where Osga was speaking, and he happened to mention that he had done this. And the guy who was in charge of finding out why the Tomahawk missile had failed was in the audience. Okay, so his final report said everybody should do GOMS models, okay, and that cost the US taxpayers an awful lot of money. Cognitive models predicted this, and it was buried. Last failure. Our IRS put out a request for proposals for a new office automation system, and 3 reasonable contenders came in. AT&T, $1.4 billion, Lockheed, $900 million, IBM, $700 million. I was not associated with IBM. Okay. So the IRS had to figure out who to give it to. They gave it to AT&T. Now, of course, what happens? Lockheed and the IBM protest. Okay, it goes to what the U.S. calls a contract examiner. Looks like a courtroom. Guy has a black robe on, looks like a judge. Okay, but he's trying to figure out, did the IRS do the right thing? Okay, first time, actually, it's called TMAC 1. He said, IRS, we're not saying you did the wrong thing, but you didn't quantitatively show that this was actually the best value for the US taxpayers. So we're going to give you another 60 or 90 days to go do a quantitative analysis. Maybe it was a little longer than that. So they went back, they did a quantitative analysis, which included models, similar to what I do, and they awarded it to AT&T again. And so it went, well, IBM and Lockheed protested again, okay, and this time they had quantitative numbers, and they could prove there were 4 risk factors. You can read all about this in a Westlaw paper, okay? This is a case that has actually made law books because it was pretty unique of, actually awarding to one that was twice as expensive. Twice as expensive, okay? And not, little run-of-the-mill companies, okay, right? And I call this a failure because I work for IBM now. Okay, you can say it was a triumph for the U.S. taxpayer that actually the IRS did a credible job on this, and cognitive modeling could have predicted this failure if the manufacturers had done that sort of thing. And I was actually an expert witness on this. I was hired by AT&T, and the only thing I'm allowed to tell you is that AT&T let me testify. Okay, what I did, you can just guess. Okay, this gets my new company's attention. You lost a $700 million contract because you didn't model. Okay, and that was only one of the quantitative factors, but it was an important one. Okay, so how might you prevent such failures? So typically, if you're doing UX design, you want to first understand what is of value to your customer. In these examples, task execution time was very important. Okay, but there's lots of other values. Discoverability. Can a new person come up and accomplish what they want to accomplish without reading any manual? Okay. Learning time. How long does it take to learn? What sort of training do you have? That sort of thing. How satisfied will they be? Will they be delighted? Okay. Or, if you're talking mobile, maybe power consumption. Okay, there's all sorts of values that you have to find out what your customer values are, design to those values, and then test the heck out of your designs to make sure that you're actually delivering value to your customer. So typically there's some sort of circle of you design, you test, you make changes, and you go around. The gold standard of testing in the industry pretty much is what's called the usability test or the user testing. You put a person in front of your device, be it this person a desktop or your mobile app or your iPad or whatever it is, and you ask them to do tasks. You measure things like how long does it take them to do it, what kind of errors do they make, how quickly do they get better at it, do they like it? There's all sorts of satisfaction scales, but it's very empirical. Now, the problem with this is it's very expensive and time consuming because it's not just one person, right? Okay, you can't do it with one, you got to do it with a whole bunch, okay? If there are people off the street, you know, maybe that's okay. If you're trying to do things for the stock market, those people are really expensive, or doctors, or pilots. Okay, so getting the appropriate users can be really expensive, really time consuming, and it's often too late. Because the easiest way to do this is when you actually have a running system. But by then you've invested so much because you have a running system, okay? So the IRS needed to know before they paid the money to have it built, okay? And sometimes what's of value can't be measured easily. So for instance, NYNEX really wanted to know about operating costs. They really wanted to know about skilled performance time. So they had to manufacture skilled people by basically giving them 6 months of practice. That's a really expensive test. So wouldn't it be great if we could replace those pesky humans with simulated users and get predictions? That's where cognitive models come in. So I'm here to tell you tonight that there's hope of doing some of this. I'm going to talk to you about what I call cognitive crash dummies, and that they are on the way. I call them cognitive crash dummies because if you list a course in a course catalog called Human Performance Modeling for UI Design, you get 7 or 8 people to sign up. If you list it as cognitive crash dummies, you get 40. Okay, so I call them cognitive crash dummies. What are they? They're basically computer-based computational models that mimic human performance in perception, cognition, motor actions. It's trying to say, what would a person do? They have the advantage of being able to be run against a design idea in storyboard form. You don't have to have a running system. Okay? So you can get your evaluation before you invest time in actual coding. And they produce quantitative predictions of things like task execution time or novice exploration behavior. How many errors would they make? What paths would they go down that you don't want them to go down? There's some things that the military does that can actually predict the effects of what are called moderator variables in psychology, like how does performance degrade when you're tired, when you're afraid, when you're very, very hot in the desert. Okay, so there's things like this that can be predicted. Okay. Now, we're not there yet. The vision of a cognitive crash dummy is not fully formed yet. Okay, but there are some tools that are ready for you to use today, and I'm going to tell you about those, and I'm going to tell you about research that's continuing. Okay, and before you ask, I can't predict this face yet. Okay, I don't know if this is boredom or sadness. Okay, we can't predict emotions yet. But there's some interesting ideas about how maybe we could predict some correlates of that, but we can talk about that later. So, the existing methods and tools can predict very well skilled performance time. I'm going to tell you about a model called the keystroke level model and how it's embodied in the tool that I created called CogTool, which is open source and free. And I'm going to tell you about some applications of CogTool in industry. There are some other methods that I'm going to briefly touch on, some safety metrics. Actually, there's a work about driving. When you have a in-vehicle information device, how far do people swerve from the center of the road? You can predict that. Okay. Power consumption and this discoverability one. So I am going to go through some of those. So let's talk about efficiency first, because that's the one that's most well researched. This has been around for 30 years. This book I mentioned before, The Psychology of Human-Computer Interaction, came out in 1983. And it presented something called the keystroke level model, where basically you express the procedure for doing something on your device in terms of, people have to type Do they have to point with the mouse? Do they have to move their hands from the typewriter to the mouse? Keyboard. Do they have to wait for the system? And a very mysterious thing called the mental operator. And the mental operator was empirically determined black box. How long do people tend to pause before they do things? And where do they pause? They pause in front of some things and not in front of others. That was empirically determined, and Cardman and Newell gave us heuristics for how to place them. Because you don't put them everywhere, okay? And they include everything that they couldn't observe. You can observe keystrokes, you can observe mouse clicks, you can observe mouse movements, but these were things like visually searching, remembering commands, doing comparisons between things, all that stuff that was happening in this area that they couldn't observe. And there's a black box mental operator. You assign a time to each one of these. How fast do people type? How fast do they point? And this black box mental operator. And then you give the keystroke level model a suite of tasks that you have determined are important to your users, and a specification of your proposed system, not the system, just a spec, okay? And it will tell you how long will it take to do these tasks on that system. So this was all paper and pencil when they presented it. There were no tools. It was a big deal when we put it in Excel so that it would actually add things up for us. Okay, so this was all paper and pencil. But back at CHI in 2008, we celebrated the 25th anniversary of this book, and this type of modeling has spread to all sorts of places. There's a whole bunch of new theories that have done that sort of thing, have come from this as the family tree, and all sorts of organizations who use these modeling techniques on a relatively regular basis. But it's not universal. And in fact, most of the things what I sent out to all my friends, do you use this modeling? We're having this big celebration. Send me your stories. And I have a whole bunch of slides on those. Not that I'm going to show you tonight, but I could. And these were almost all PhDs in psychology who had the stories or doing it. And so that's actually a problem. Because if modeling is so great, how come everybody doesn't use it? Well, the hypothesis is that cost-benefit drives everything that everybody does. Just like interactive system designers also get up in the morning and say, what's my most important thing to do and how hard is it going to be to do it? And the costs associated with human behavior modeling are perceived to be too high. Too high to learn, too hard to learn. You have to go get a PhD in psychology, okay? And too hard to do even after you learned it. That's the perception, okay? Those of us who love it don't believe that, but that was the perception. And the benefits are too low, perceived to be too low. A lot of people say, well, we don't really care about execution time. Now, the folks who lost all that money on the first 3 examples, they care, okay? But maybe, your company doesn't have a big value on skilled execution time. That's not the only thing of value. But the other things are even harder to do than skilled execution time. So this was the hypothesis that I had a few years ago, about 2003-ish. And so I went out and I did user-centered design, because here we had a process that worked and a user base that couldn't use it. So guess what? That's just user-centered design, right? So I know how to do that. So I went and studied the UI designers and found out what do they know, how can I connect to them, how can I speak their language, and I created a tool called CogTool. The goal was to make it easy, so easy to use, that we would reduce the cost of learning and the cost of creating valid cognitive models. And we have this toe-in-the-door philosophy that first make the really simplest models easy, really easy, and then gradually expand the power of the tool without sacrificing that usability. So I've been working on this for quite a while now. And we are now starting to expand the scope of what the models can predict beyond office work, beyond measures of just skilled execution time. And the rest of the talk's going to tell you first about CogTool and then about the research. So with CogTool, you do a keystroke level model. It's the same theory that was in that book that actually had hundreds of papers validating it, okay? If you do the predictions and you measure it, you find that the predictions are within about 20% of the measured skills. And that's Remember, I'm an engineer, 20%, pretty good. Okay, you can weed out a lot of bad interfaces that way. Okay, so what you do here is you mock up your design in a storyboard. And UI designers use storyboards routinely as ways to communicate their design ideas. So this is not anything foreign to them. Okay, then you demonstrate your tasks on your storyboard. Again, this is how they communicate their design ideas to the development team. They give them a storyboard and they go through each screen. Now it's going to look like this, and now the user's going to type here and do this, and then it's going to look like that. Okay, so the creating the storyboards and demonstrating things on the storyboards are very much in line with what a lot of UI designers do. Then our prototyping tool, our storyboarding tool, has, oh my goodness, a little button. Well, that's got a big button. That says compute. You hit the compute button and you get magically a valid prediction of how long it's going to take a skilled person to do these tasks. Comes out in a spreadsheet-like form. You can export it to Excel, do whatever charts you want with it. And even better than that, it's not just the numbers. The good thing about a model is you can open up its head and say, what did you do? How did you get that time? Where is your process? And this is a timeline visualization. This is what the system's doing. It's presenting each one of those frames in the storyboard. This is where the eyes are moving around in purple. This is where that thinking time happens. And the red is what the hands are doing. This is a pattern for typing. Lots of stuff, right and left hand. These are points and clicks. Okay, so you can see what the cognitive model was doing under the hood. And you can compare two of them, or more, okay? But this one is interesting. So this was a homework assignment I gave. Did you guys do that homework assignment? Yes, she did that homework assignment. Okay, some of my alum are in the back. This was their homework assignment, okay? And these guys were great because they all got the right answers. I actually did a paper on how consistent her class was. And what I asked them to do not only is predict which, these are library book collection websites, not only which one would be faster for different tasks, but to come up with design recommendations. And looking at these visualizations, you can see that, for instance, BookTagger is faster to do this particular type of thing, and the same for typing the tag, but then it loses some over here. Okay, so you can go in and see where different systems are better or worse because you can compare these timelines to each other. And designers, these are people who, they heard one little lecture and they went off and did their homework. And they could consistently get the right answers. I can give you all the statistics of what the coefficient of variation is. It's like 7%, which is fabulous. And they can get design recommendations from it. Okay, so this is a tool that is ready for you to use. You can download this from the CogTool website. It is open source if you want the source, but there's executables there for Mac and PC. There's tutorial materials, there's videos, there's a reference guide, there's examples. You can use this today, or the people in your company who do UX can use this today, if skilled execution time is of value to your clients. So I was going to tell you now about some of the places that IBM has used it in the last 2 years. So we're going to go through 5 with varying degrees of detail. Most of them look like silly names of products. That's because I'm not allowed to tell you what the products are. Okay, I can tell you a little bit about them, but I can't tell you what the products are. So let's talk about the first one, because that's the first one. That's the one I actually can talk about. Thank you. Oh, thank you. So this one is a government project that we can actually talk about and have published papers about. Okay, so John Richards was the manager of this when I first started talking to him about this. And he said to me, I have a bidirectional time travel problem. And it's this project called PERCS. It has a Wikipedia page. It's a big deal. It's called Productive, Easy to Use, Reliable Computing System. Okay, and it was a DARPA project that had new chips, new computer architecture, new operating systems, new compilers, and new programming environments for parallel computing. Very large-scale parallel computing. Now, if you are familiar with DARPA, you will notice this is a DARPA slide. It looks like a DARPA slide, okay? And it has all sorts of words on there about what the goals of the project are. And the most important thing is that they were looking for speed up of end-to-end performance of 10x. Now, I don't know how many proposals you have read to the government, but everybody claims they're going to get 10x something, okay? And nobody ever gets 10x, okay? But I'm a little proud of our government because they actually wrote into IBM's contract that they would not get the last increment of money, which is a lot of money, unless they showed 10x improvement. So as a US taxpayer, I'm really happy. As an IBM employee, I'm worried, okay? Well, it's over now, and we got the money. Okay, just finished, I don't know, 2 weeks ago. But here's the bidirectional time travel problem. They were contracted to deliver 10x performance improvement. They were told that it had to be 10x above 2002. But DARPA didn't provide a baseline. So he was going to have to travel backward in time to 2002 to establish a baseline, because he had to find the computers, and more important, the people who knew how to use it with their 2002 brains. Because if they had learned anything since 2002, it doesn't count. Okay? You know, so they had to go backwards in time to do that. And originally, the prototype delivery date was 2011. It slipped a little. It was actually a couple weeks ago. But he had to deliver the proof at the same time as the delivery date. So he had to travel forward in time so that people could actually learn how to do this, to collect the data, to compare it to the data he had gotten back in 2002. So this is his bidirectional time travel problem. He was tasked with doing this, and he had no idea how he was going to do it. And I said, oh, that's easy, John. Models can mimic the knowledge of users at any time. So we can model what people would have known in 2002 and the systems in 2002, and then we can model what they will know in 2013. And so he said, oh, that's a good idea. And so they actually had me out for a sabbatical in 2009, 2010, which eventually turned into to my new job. So we did do exactly this. We modeled the old system, and in this storyboard, a little more detail about how you do things in Contool. These were existing systems, so we could take screenshots of them. Okay, you don't have to. You can sketch with it. You can make sketches and scan them in. You can actually use it as a blank canvas. You can import things from HTML, which kind of works. Okay, and so you're basically trying to get what the user would see. And then on it, you put hotspots of the widgets that they need to do their tasks. So you would draw a little button with a button widget tool, or a text field, or a menu. And those are the things that you can barely see in orange. Well, so that says keyboard, but like this is a link that somebody's going to click on. Okay. And then the arrows that connect are called transitions. And so they say, so it's like if you're on this screen and you click this, you get to this screen. So that's how it's representing that. The transitions represent what the user does, and the screen represents what the user sees. Okay? Then you demonstrate your tasks, and as you demonstrate, so the window for demonstration comes up, and you've got the first screen, and then you go and you click on the thing that they have to click on first, or you type, you click on the keyboard and say, I'm going to type such and so. And Contool is watching what you do, and in white are the things that you actually did. So like here you're typing a couple of things on the keyboard. Here you're left clicking on a link. Okay. The yellow is the psychology that we put in for you automatically. And so we're putting in this think time for how long do people tend to pause based on prior empirical studies. Okay? And then you basically hit the compute button and you get your spreadsheet. Now, this was an early one. We've only done a couple of tasks before we published this. As you can see, they're not getting their 10x yet. Okay, but I can tell you that they did get the money a couple weeks ago. So, and the system's out. So it was successful. We also could look again at those timelines. And so this was the old command line interface versus our new Eclipse-based interface for getting help. You can look at the comparisons and say, well, you know, why are they better? Because you kind of want to know why, and DARPA wants to know why. Okay, so you can look at that. And this was one of the things they delivered to DARPA was all these models, and they did like 300 models. So this is this was the project that at IBM that I can tell you the most about. Okay, because it's not real products. I mean, it is real product, but it's a publicly funded product that I can tell you about. And so that was, the benefit was contract compliance. Okay, this was a line item, delivering these models was a line item, and it was part of the contract. So it was kind of done at the end. A different project called Do It was for revising a product. And let me tell you a little bit more about that. They had customer feedback that said, we're not happy with your product, it's slower than your competitors. And the developers said, oh yeah, we know about that. It's because people have to keep signing in. And if you use IBM systems, you may have noticed this. Okay. And they said, well, we just have to solve the single sign-on problem. And so they did some modeling to validate this hypothesis, and say, did they, you know, was this going to be enough to make our customers happy? So they did models, and it looked like this, and sure enough, they were kind of on a par, in fact, a little bit better than their competitors in the very beginning part of a task, but boom, all of a sudden you had to sign in, didn't have to sign in the other system, but there was this extra thing, that this pattern here is the same as this one, but there's this extra step. And so the modeling actually said, yes, developers, you're right, the single sign-on is a problem, or no single sign-on is a problem, but there's another problem. And they could look at that and say, oh, maybe we can do something about that too. So the models uncovered an additional problem, and the things, the project managers were so happy about this, because what they said was, we have been talking about this for years. These pictures let us stop talking and prioritize and move on. Okay, so it's no longer opinion, it's analysis and quantitative analysis. And project managers were really happy about that. Another project they call Sharing was, again, looking at an existing system versus competitors. And here, they not only communicated within their team, but also to the customer. So a very important IBM customer expressed severe dissatisfaction with the efficiency of a current product compared to competitors' products. And the Cogtool analysis was done by the, the product team, and they actually brought it to the customer. And they said, we have found this problem. You're right. We're slower. You're right. But we now know what the problem is, and we can fix it. And they found that these timelines and the storyboards were a very effective communication tool with customers. And they didn't lose that customer. Again, I can't tell you a lot about these, okay, but that's what happens when you talk about industrial stuff, right? The next one was actually in beta test phase. There was a portal. This was, I can't tell you who it is. Anyway, they had an old portal for information for the internal customers, and they had put out the new one to some beta testers. And the early adopters, these beta testers, started complaining like crazy. They say, this is slow, we can't stand it, this is slow. But now the question is, whose fault is it? Because they changed a lot. And what would happen? Well, the back-end people say it's that UI. UI people say, oh, that's the back-end. Okay, that's what happened, right? So we got to do the Cogtool analysis and play what if. We could say, what if you have no system response time at all? It's just all instantaneous. Is the UI slower? Well, it turned out no. The UI was faster in terms of the number of things that people had to do and where they had to think and everything. The UI was faster. And so since you can play what if, as opposed to when you're actually user testing, you have to measure everything, and you can't say fast system response time, please, magic, you know. They could say the problem actually lies with the back end and the communication with the back end. So now they know who to set to fix it. So this gave the project managers appropriate staff information for their staffing. Okay, so again, the project managers are very happy with these analyses. Okay. And then the last one, they were, there's a particular type of thing they were trying to do, and there existed 8 different ways of already doing it in different IBM products. And they were going to unify this, and they wanted one way to do it. But the one way to do it better be better than any of those existing 8, or at least as good. Can't be worse, because there were already customers doing all those other 8, right? So you didn't want to make anybody unhappy. Okay, so they did the 8 models of the existing ones plus the model of the new proposed system, did it all in 8 hours. It was one day. You know, this is not a long, drawn-out process, okay? And they could come into the meeting the next day and say, look, our new design actually will be better. And again, no more discussion, move forward. So this is the sort of value that IBM has been getting out of using these models. If you wanted the details on this, was actually a case study at the last ICSE conference, International Conference on Software Engineering. And so this is some of that value. Now I'm going to move into the research part. So remember when I introduced Cogtool, I gave you what the goals were. What I said, we were now currently expanding the scope of what the models can predict, new domains, new metrics. So that's where we're going now. We've done models. This is work that I did when I was at Carnegie Mellon with NEC. We compared 3 different cell phones on 10 different tasks. Our models get big, our storyboards, our system doesn't crash when you scale to lots and lots of models. We looked at these 3 different phones. One was an NEC phone, one was Casio, and the iPhone. And Cogtool did really well, because they did empirical work as well, because they didn't trust the models yet. And for the 2 phones that use just keyboards, phone keyboards, really good predictions. Remember, this includes that mental time. You know, that's pretty big. So people were actually, skilled people were stopping to think about things just as the model predicts. Okay, iPhone, not quite as good. That's probably because we didn't have the new motor operators, like flicking. We don't know how long that takes yet. We're now doing research on that to be able to put those into the model. We're really good on tapping, but we don't know these gestures yet. But still, 13% isn't bad. So we've gotten off the desktop onto some of the devices that you may be more interested in modern. And there's a bunch of other papers on these sorts of things, tablet stuff. A lot of people using, one guy at CMU did watches for elderly people doing diary studies to keep track of their health. And they had these little wearable computer things that they did great models, and they said, oh, it was all within 10% of what it actually took in the field. So they were very happy with that. We can do, we've done work with driving, with in-vehicle information devices. An old version of Cogtool, you could actually hook it up to a driving simulator. And this is a very, not sophisticated driving simulator. Okay, but here's a road, and it's hard to see in this, but these are little cross hatches and things. This is where the eyes are, and they move around, and it's peripheral vision versus the foci, focal point. And this is where the steering wheel is, where the right hand would be, and this is actually the right hand as it's moving across to your cell phone. Okay, and there were videos on this. I mean, it would actually run and stuff. Unfortunately, it suffered from code creep. This is when we had a grant from GM, who stopped funding research. We can believe that, right? But there was a man named Dario Salvucci at Drexel. And he's got this great system called Distractar that's very similar to Cogtool. Well, he worked on Cogtool before he went to Drexel. And he's got a great little YouTube on it, on how to do this, so make little in-vehicle devices that then gets combined with a full driving simulator. There's a great model of driving in it. And he can get, I don't have time to play the video for you, but he can get those measures, those safety measures. How far away from the center of the road does someone swerve as they're using this information device, and their braking speed. How many feet does it take for them to brake? Because when you're looking at this thing over here and the eyes are moving over here, you don't see the brake lights in front of you. And so he can transform these sorts of models, very similar, like I said, to Cogtool, into safety metrics that people really care about. Okay, because nobody cares how long it takes to find the nearest Starbucks, right? Okay, well, you might because you want to get off at the exit. Okay, but the people in the cars around you really care that you're not swerving. Okay, so this is a really great system. We've worked with Boeing on doing modeling on the flight deck and some of the new things that both Boeing and NASA are studying. And sure enough, we actually get, again, about a 10% difference between what's predicted and what's observed with human data. 10% sounds pretty good, but I have the little caveat. What is it? It's within 10% of what a skilled pilot would do at a computer simulation of a cockpit, not necessarily at in the actual cockpit, and it's very hard to get those data. But they do use computer simulations to test new systems. So we're doing quite well in that. And this is another situation, this is the situation where it's really expensive to get skilled pilots to come in and do user tests for you. They are busy and they are expensive. So this could be a stand-in and weed out those not great interfaces so that maybe you only have to test one or two. Okay. And even with these limitations, they're pretty excited about this sort of thing. So all of these things that I've talked about so far can actually be done with Cogtool or have been done with Cogtool, caveat the code creep. But some of these new ones don't have the 30 years of validation behind them yet. It's still in process. I'm going to move on to other metrics, but does anybody have any questions about skilled execution time? This is the academic in me. You know, yeah.
What do you mean by skilled person?
Okay, so there's a very specific definition in psychology of what skill is. Skill means you can recognize the situation that you're in and know how to get to the situation you want to be in. So you're not problem solving. Okay, problem solving is, well, I kind of know where I am, and I sort of know where I want to be, but I might go down dead ends and back up. Okay, a truly skilled person, they can still make errors along the way. I mean, their finger can slip off the mouse. Okay, but the definition of skill and skilled performance is that you know what to do to get from here to there. Okay. Okay, so let's talk about the new exciting stuff. Oh, I already told you about the extracting design recommendations, so I won't talk about that yet. Again, energy expenditure. Now, this is a thesis that was done a couple of years ago by a woman named Annie Liu at CMU. Hasn't gotten a lot of work since her thesis. But what she did was she said, okay, Cogtool has a way to get me predictions of user time. And I can find out how much power it takes to do specific things on a PDA. She was a couple of years ago, so she was doing Palm and a couple other things. Okay, and I can map these energy profiles that I can measure. Just how long, what sort of energy, what sort of power consumption is it when the person presses a button? What sort of power consumption is it when they're using speech recognition? Okay, they have different energy profiles. And she could map those energy profiles to that visualization and come out with a prediction of how much power you're going to use so that you can see that different methods drain your battery differently. Okay, so here's the kind of mapping. You can see, so she predicted that she could look and say, okay, these are all keystrokes on the tap, 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 tap. Okay, and these are the energy spikes that come from the keystrokes. And so she did predict, this is another example of off the desktop, these could predict the time that people would take, very good, within this 10% that I kind of like, those 10%. And this is the prediction for the power consumption. So she's getting within 10% of the power consumption for different things on the phone. You won't be surprised that she walked out of her PhD and got a job in Nokia. Okay? So, so this is another metric that people never thought cognitive modeling would help with. Right? That's like way out there. This is one of the most novel PhD theses I had seen. It's really exciting. So there's a metric that some people may be interested in. This is the one that lots of people want. Okay, predicting exploratory behavior, or what some usability people call discoverability. Okay, so for instance, if you're given an information finding task, or you have one, an information finding task, and you have access to the web, how would you find that information? Or if you want to do something on a new application, what would you click on? There's a theory that's called information foraging. It came out of Park. And the reason there's a bird is because this theory is based on foraging theory for animals. There's a mathematical theory that predicts where if birds are eating berries, and they're on a bush and they're eating a berry, what's the likelihood that they're going to stay on that bush versus fly off to another bush? Because it takes energy to fly off to another bush. Okay, and you're trying to get food, and that's energy there. Okay, so that's foraging theory. It's a lot of math. Okay, but it predicts animals pretty well. And guess what? Humans are informivores. We consume information. And you can apply that math from foraging theory to human information foraging. And we have taken their theory and built it into CogTool, into a version called CogTool Explorer. This is available. It's in our open source. You actually get it when you download CogTool, but it's not documented. Okay, other than Liang Wei's thesis, Liang Wei Tao. That's the problem with research. You got to stop and do the documentation, okay, until people can use it. So instead of demonstrating a task, you still make your storyboard, but instead of demonstrating of how a skilled person would do it, you give CogTool Explorer a goal. And you say, go. And it has a model of this information foraging under the hood, and it gives you predictions of where people would click, given this goal on this interface, including the errors they would make. So here's kind of the way it works. This was a study done at University of Colorado. The tasks come from there. Their task was they gave you an information finding task. This, if you could read the gray, you would see it says canon law. You're looking for the laws associated with a church. And then they have the topics, I can tell you how old this was, from Encarta. Okay? Okay, and so they had people do this. But Liang Wei Tao, his PhD thesis was to have CogTool Explorer do this. CogTool Explorer has an eye, and it moves its eye around, and it looks at the links, and it evaluates how related is this link to my goal. And that's called information sent. Does this link smell good? You know, is this a good berry? You know, okay? And then it keeps looking around and it evaluates the information sent and has a lot of math under the hood to decide, is it better for me to look at the next link, better for me to go click on the best one I've seen before, or better for me to go back a page? Okay, so it's making all that decisions based on a psychological theory. It's got a lot of math in it, okay? But UI designers don't need to know the math. They just need to tell Cogtool Explorer to go. And so it looks around, finally decides, oh, I'm going to go to that best one I found so far. Clicks on this, gets another page, keeps going. Okay. It works on, it takes into account where things are on the page and grouping. So, you know, at first it decides what group to go to, then it looks in the group, decides, oh, I don't like this group, you know, goes to a different group, oh, I don't like this whole page, goes back, you know, so it's doing this complex behavior. And what we get out of it, this was a paper at Chi last year, so we had 36 tasks like that, and Colorado collected the data on what percentage of people were able to solve this or find the right thing within 130 seconds. And we ran Cogtool Explorer for 130 simulated time, seconds, a lot faster than that. Okay, and we also got a percentage of model runs that completed the task. And the green are things that are easy for the model, and the tan are things that are hard. So what's important is that will this direct your design effort correctly? So you want a model like this to tell you these things will be easy for people. Don't touch them. They're okay. Don't waste your time redesigning. And these other things are going to be hard for people. This is where you put your design effort. And so that's what this down here, which is the bottom, tells you. So the correct identification of an easy task got 93% of the easy tasks. Correct identification of a hard task, again, 93%. That means that we're only going to miss one problem out of 14 that was hard. We're going to direct you to design on the hard stuff, and we're not going to have very many false alarms, which means the model tells you to design something that doesn't need it. Okay? So this is my engineering coming in here. Okay, because the science isn't perfect yet. We are accounting for about 70% of the variance, if you like psychology terms. Okay, so it's not perfect, but it's good enough to direct your design effort for your next version, or for this version before it gets out. Because remember, this isn't done yet. This is just what the layout of the page would look like in a storyboard. Okay, so models can be run to get this sort of information about discoverability as well. Again, this doesn't have 100 papers behind it. It's about a half a dozen. But this is ongoing research. I'm going to bring it into real applications and other really interesting stuff. So, my hopes for this session was that I convinced you that cognitive crash dummies are possible. There's a lot of people who say we can't predict people. Can't predict people. I hope I convinced you that that's wrong. We can't predict everything, but we can predict something. Some things. Okay? I hope that I've intrigued you sufficiently that you might think about modeling, and particularly with Cogtool. Now, if skilled execution time is important to your customers, you just go download it and play. Send me an email if you got questions. Okay? And I hope that I've enticed you, to learn more and to contribute to research. We need data. Okay? We want to validate that discoverability thing. So we'd love to partner with people who do usability tests and have data on how novices use their system. Then we could try to predict it, and validate those models and make it better and better and better. So that's the end of me. Thanks to everybody here and there. Okay, and any questions?
Okay, I'd like to open up for questions for Bonnie.
Yep.
So I have a question. You said that you did the models for skilled users, but did you look at different user bases, say like the elderly versus?
We have research going on with that. Also, there's been some other work. So I'm not the only person who does these models or research in these models. A woman named Tiffany Jastrzemski. Is that how you say her name, Gary? Something like that. Okay, she's now at the Air Force. But she got her PhD in Florida, where they have a lot of research on elders. And she did this type of modeling for elders, and she changes the parameters. And so we worked with her to build that into CogTool, and it's still part of the research. Again, it's not the documented part, okay? But there's a little checkbox hidden in CogTool that says Enable Research Commands, okay? And you can get to that, and I can tell you where to get to it. And there's a place in there that you can change the parameters that says Use Older Adult Parameters. And then you can get closer to older adults. So we have done some work in that, and we're continuing with that because there's a woman at my research, the group that I'm in at IBM has a collaboration with the University of Dundee in Scotland, again, who has a very active elder research community, and we're continuing research on that. Yeah.
Hi, I'm wondering if you could research on electronic medical records.
I have not done research on that, okay, or application on that. However, there are some medical papers that other people have done it on. And if I could get to the web, I'll show you. I would like to just show you the CogTool. Oh, this is the YouTube about the driver. This was me trying to find pictures, but let me get to, wait a second. So, go to the CogTool website, and there's, on the right-hand side, there's research projects, and I believe there's a couple on medicine. I keep trying to update it. Not everybody puts their stuff in. But the CMU Quality of Life Center has done some work on medical, and some people at Pitt did some medical as well. If you can't find it, send me an email, and I'll see what I can find. Okay. What Ditya was asking first.
I don't know if I missed this, but I just wanted to know some more details about measuring information sent off a link, like what all attributes are taken.
Sure. So, yeah. So, information foraging theory and its embodiment in CogTool is pretty complicated. There's a whole book on information foraging, okay? The way information sent is calculated, there is ahead of time, you define what you expect your users to know by making a large corpus of documents that say, I expect my user will know something like this. The work that I showed here was using something called the TASA corpus, which is a sampling of everything that a US student up through first year of college would have expected to read. It's a relatively old corpus. It's from the 90s. And so that actually makes it a problem. It's fine for these Encarta tasks, okay, because it's encyclopedia sort of stuff. But, so for instance, I put in, my goal was to surf the web on an iPhone interface with that Safari button down here. Well, TASA knows about surfing, or the surf. It knows what webs are, and it knows what a Safari is. But it doesn't think they're related. Okay? So we've been looking at using more modern corpora, which are now the representation of what you think your user will know. We just put a paper into Chi last week using Simple English Wikipedia as a stand-in for what a modern person in the United States might know. or at least an English speaker. Okay. Then you have this corpus. And then there's a lot of math. We use something called latent semantic analysis, which makes this into a 400-dimensional vector. Okay? And then it takes your goal, which you've written out in text, and it takes the label that Cogtool sees on the screen. And it makes vectors, it places those in this 400-dimensional space, and then it measures the cosine between those. And the higher the cosine, the more similar these things are. So it's doing all that math under the hood, and it comes back with a value. This link, or this button, is 0.9 good for your goal, and this one is 0.001. And Cogtool then takes that into consideration based on what else it has seen, whether it's already clicked on this thing or not, so it's not stupid and keep clicking on the same thing when it failed, you know, okay? It will forget and go and click on it again, and people do too, okay? But, you know, so it takes all of that into account, but this information sent is based on the corpus that you've said, this is what my user will know, as an approximation of what you think they may know. And the TASA actually has one for 3rd grader, for 6th grader, for 9th grader, for 12th grader, and for first year college. So you could actually, it's another thing, not elders, but youngers, okay? But that one is pretty old, and so it doesn't know about Safari being a browser for the World Wide Web. And so, so that's it. It's the corpus, given your goal, given your UI, and a whole lot of math to decide how similar your goal is to your UI labels. Yep.
Along the same lines, so if someone had a task that they wanted to find this document on that particular page, but one of the business objectives could be, we also want them to explore other things that we have. Is there a way to predict that?
Well, yes, because Cogtool has an eye, right? So it will predict what things on the page it will look at before it finds the link that they wanted.
Right.
So you can get some of that, okay? And it has something, a parameter called called K. It's how anxious is this person to click, okay? And so with different values of K, they will click on something faster or give up faster. So I can't tell you what percentage of your customers have what K, but you can play what if. You can say, if I have really impatient people, will they see what I want them to see? Or will they give up? Okay? Or if I have really patient people, like the person who's just diagnosed with cancer and really wants to read everything. Okay? And so you can manipulate that K, and that's one of the parameters. Again, not document. I mean, it's in the thesis.
Right.
It's not, there's no user manual for that. Okay? Okay. Yep.
Hi, Bonnie. How you doing?
Okay.
Great presentation. I find it very insightful.
Thanks.
Do you have any, can you talk about any criticism of your models? Do you have any examples of where your models were wrong, and what, and if they were, what
Yeah.
did you learn from that?
Yeah.
And another question is, when you showed the energy profile slide, when I saw that, I was thinking of something completely opposite, like the energy expenditure of a human using,
Yeah.
a device. Have you done anything like that?
Yeah. So the first question, criticism. There are some people who just don't believe it. Okay, they just don't believe it. So, I mean, the person who wrote the paper with us on all those 5 different things that happened at IBM, her boss said, I don't believe it. Okay, I don't believe your models. You have to come over with a stopwatch and time me. Okay, and he said, it doesn't take that long. It took that long. Okay, so that was fine. And of course, one of the things that everybody wants is we know people work at different paces. Okay, and so they don't want one number. The one number is an average. They want to see the distribution. And we have some work on presenting a paper at Human Factors in the middle of August that we've joined with another project at RPI that can predict the the shape of the distribution, and of people doing the same thing, but doing it slightly faster, slightly slower, and actually get a distribution. So that's been one of the criticisms before. It's especially important in aviation because they have things they have to do. Air traffic control tells them to do something in cockpit, and they have a time window. And so they may do everything right, but if they don't do it fast enough, they'll miss their waypoint. This has big economic consequences, because if they miss a waypoint, they are relegated to a less desirable path, which uses more fuel. Okay, so they really wanted to know that distribution, because they don't want to just say this procedure is okay. They want to know what percentage of pilots will be able to do it in the amount of time we're giving them to do it, because pilots complain they have too much to do. So for some people, for some applications, it's a lot more important. But that's been one of the criticisms. This is a research tool that's very fragile. It's student code at RPI, but we've shown the feasibility of that. The other thing everybody wants is that novice. They said, yeah, skilled performance time is fine, but what we really want to know is what novices are going to do. And they don't trust the models yet, with good reason. They've been validated on web searches. And when you're talking about, can I use my new iPad app, that's not a web search. So we haven't had enough data to validate that. Yep.
You actually just touched on what my question was going to be, novices. How do you, you talked about skilled users, but if you have people that have never seen a particular system before, they're novices on that system.
Yeah.
So,
well, that's the information sent. That's the last research direction that I told you about. That is predicting novice exploration paths. They have a goal. What are they going to click on? How are they going to back up? Are they going to be able to accomplish their goal? That is very current research, and we're doing fine on the things that we've validated so far. But we need to expand to other applications, real applications, get more data. Give us data. We'll make a better model for you. Okay, but that just needs a lot more validation. You can really trust those skilled execution time predictions now, but the novices is the really current research.
Similar to that question, how would you, do you have any predictions around people missing an important, on the cockpit, I missed that particular dial that was just telling me I was going below 10,000 feet or something like that. In other words, design of things like that. Or I missed the EMR, I missed that vital sign that told me I should have been paying attention.
We don't, I don't have any, I'm not, sorry. What you're talking about are errors that skilled people make, okay? Skilled people still make errors, okay? We started to do some work with NASA on that, where there was a routine task, a monitoring task, how are things going, how are things going? And an alarm went off, okay? Now, how do you interleave these tasks, and how do you model that interleaving? Because as soon as when an alarm goes off and you have to do something, then you're stopped doing the monitoring. If you're paying attention to the alarm, you may miss something that's coming up. And so we started to do that work with NASA. They lost funding, we lost funding. We believe that the modeling framework can do it. The underlying cognitive model is something called ACT-R, which is an active research framework for hundreds of researchers around the world. There are people doing that sort of multitasking stuff in ACT-R. It hasn't been brought into a usable tool yet. It's basically PhD psychology level research in multitasking. But I pay attention to what ACT-R does, and when it gets to a point where you can trust it enough, I suck it into CogTool. So what kind of I'm the amoeba of good research. Okay, but there are a bunch of people doing actually multitasking stuff in ACT-R that you might be interested in. Yep.
In the beginning, you mentioned that it's not able to get emotion.
Yeah.
Do you have some ideas of how to?
Yeah, there's some interesting. There's lots of work on in the academia on modeling, not modeling emotion, but kind of the correlates between cognition and emotion. Okay, and there's some interesting stuff that we did when we worked with NEC. There was a correlation between the time it took to do the tasks and how satisfied they were with the phone. Both with experts, so people who had had the phone for 6 months and really knew how to use it, that was actually a stronger correlation. The more efficient the phone was, the happier they were with it. And even with novices, with as little as an hour playing with it, it was a significant correlation between how quickly can I accomplish my goals when I don't know how to do that, which is the information sent sort of stuff, and how happy they were with the phone. So we're starting to find some correlates with cognition. It's not going to be, am I delighted yet? Do I love this? Not that yet. But we are finding some correlates with the things we can predict. Yep.
Just wanted to ask one thing, can this model predict if the human is not interacting to the screen, but the information on the screen itself is changing? It's not physically interacting to going to the next screen, but the information is changing.
So an older version of CogTool could do that. Okay, because we used that when we were doing the driving stuff, because the road was changing and the brake lights would go on and the curves would happen. Okay, the newest version, that's the simplest to use. Actually, you can't do that. It is the underlying psychology can do that. The Actar can do that, but we haven't built an easy-to-use GUI to specify how that would work in your system.
Okay. Thank you very much.
Thank you.
Just a couple of quick points here. If anyone's actually interested in information foraging theory, probably the best current book is by Peter Parolin, Xerox PARC. So if you just go to the web and Google up information foraging theory, a relatively thin book, lots of math, but also some very good text for the general reading. But that's probably the single best text. Okay, thanks everyone. And please come to our session on Apple versus Samsung. It'll be great. Thank you.